Hi, this is Mr. Hebert, and this is about ellipses. So to get to ellipses, let's start with the circle formula. You're familiar with x squared plus y squared equals radius squared. Here's an example circle. X squared plus y squared equals 36. This would be a circle that begins with, a radius of 6. Let's imagine, though, that we're going to divide both sides of this equation by 36. Then we'll get this. X squared over 36 plus y squared over 36 equals 36 over 36, or 1. And you notice how, in this way, we've sort of got the radius separated for x squared and y squared. Well, that's exactly how you do it for an ellipse formula. In an ellipse formula, you actually get to choose your horizontal radius and your vertical radius separately. Your horizontal radius goes under the x squared, and your vertical radius goes under the y squared. So this is going to create an ellipse that's got a horizontal radius of 9 and a vertical radius of 6, an ellipse that is sort of longer than it is tall. And there's a picture of it. See, horizontal radius of 9, vertical radius of 6. You could, of course, change either one of those numbers. And so the general formula for an ellipse looks like this. X squared over a squared, where a is the horizontal radius, plus y squared over b squared, where b is the vertical radius, is equal to 1. If you can choose any numbers for a and b, then, well, you can get the ellipse to look like what you want it to look like. And here is a little visualizer I created for Desmos. There's that radius that we're familiar with, 9 on the horizontal radius and 6 on the vertical radius. And we can certainly change them. You can make ellipses that are taller than they are wide, by a lot if you want. Or, interestingly enough, if you make the vertical radius and the horizontal radius the same, well, then you have a circle. A circle is a special kind of ellipse. All right, that is the basics of ellipses.